Alright, so in this problem, I have 5,555 squared minus 4,444 squared. So to solve this, well, to start, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So, if you notice over here, well, this is in the form a squared minus b squared, because a in this case is 5,555 and b is 4,444. So now if I put this in the form a plus b times a minus b, I'm going to get a plus b, so 5,555 plus 4,444 times a minus b, so 5,555 minus 4,444. Now, to solve this, well, 5,555 plus 4,444, that's going to be equal to 9,999. Now I have this times 5,555 minus 4,444, which is 1,111. So now I want to multiply these two, but as you can see, it looks pretty challenging because both of these are really big numbers. So the easiest thing to do is, well, we see 1,111 here, and this is a multiple of 11. And because it's all ones, it's going to be really easy to multiply with this number. So what I'm going to do is I'm going to rewrite 9,999 as 10,000 minus 1. So I have this times 1,111. And now I can go ahead and distribute. So 10,000 times 1,111, that's going to equal 110,000. So now I have this minus 1 times 1,111, which is simply just 1,111. And now I'm going to go ahead and subtract these two. So 11,110,000 minus 1,111, that's going to equal 11,108,889. So this is my answer to this problem. Alright, so in this problem, I have 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. So I want to find the value of x here. So for my solution, I first start with 2 to the power of x minus 1 is equal to 3 to the power of x plus 1. Now I'm actually going to take the log on both sides. So now I have log 2 to the power of x minus 1 is equal to log 3 to the power of x plus 1. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 2 to the power of x minus 1, and I can move x minus 1 to the front. And log 3 to the power of x plus 1, I can move x plus 1 to the front. So now I have x minus 1 times log 2 is equal to x plus 1 times log 3. Now, if I distribute these two, I have x times log 2 minus log 2 is equal to x times log 3 plus log 3. Now I'm going to subtract x times log 2 on both sides and add log 2 on both sides, subtract log 3 on both sides. So then these two cancel out, and I have negative log 2 minus log 3 is equal to x times log 3 minus x times log 2. Now if I factor out x from here, I get x times log 3 minus log 2 is equal to negative log 2 minus log 3. If I divide both sides by log 3 minus log 2, I have x is equal to negative log 2 minus log 3 over log 3 minus log 2. Now, if I multiply both sides by negative 1, I get x is equal to log 3 plus log 2 over log 2 minus log 3. So this is my answer. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 here as x to the power of 3 times 2. So now I have this minus x to the power of 3 minus 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, x to the power of 3 times 2, I can write as x to the power of 3 to the power of 2. Now this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now I have y to the power of 2 minus y minus 2 is equal to 0. So now to solve this, we're simply going to factor this. So I'm going to rewrite this as y squared minus 2y plus y minus 2 is equal to 0. And now I can factor by grouping. I'm going to factor these two together and these two together. So from y squared minus 2y, the greatest common factor is simply y. So I have y times y minus 2 plus, from y minus 2, the greatest common factor is simply 1. Now, if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 equals 0, meaning y is equal to 2 and y is equal to negative 1. So now recall how we let x to the power of 3 equal to y. So this means that x to the power of 3 is equal to 2 and x to the power of 3 is equal to negative 1. So if x to the power of 3 equals 2, then I'm going to take the cube root on both sides. The cube root of x to the power of 3 is x, so I have x is equal to the cube root of 2. So that's one solution of x. And now for x to the power of 3 equals negative 1, again take the cube root on both sides. Cube root of x to the power of 3 is x, cube root of negative 1 is still negative 1. Now to check, I'm going to plug these both in. So let's plug in negative 1. So I have negative 1 to the power of 6 minus negative 1 to the power of 3 is equal to 2. Negative 1 to the power of 6 is 1. So I have 1 minus negative 1, which is equal to 1 plus 1, which is 2. And for the cube root of 3, if I plug in the cube root of 3, well, that's going to be 2 to the power of 1/3 to the power of 6 minus 2 to the power of 1/3 to the power of 3 is equal to 2, which is 4 minus 2 is equal to 2. 2 is equal to 2. So these two solutions are right.